Hi, I'm Danny.
Hi, I'm Helen, and welcome to MindSpore Tech Day.
In this MindSpore Tech Day series, we will discuss the definition and evolution of AI and AI frameworks and introduce our all-scenario framework, MindSpore, and the community behind it. During the live stream of each episode, if you ask a question, you will get the chance to win a gift card. We will also have a quiz session. If you're the first to get the answer right, you will win a gift card, so don't miss out.
In this first episode, we shall talk about the basics, history, and development trends of AI. Although AI has been a hot topic in recent years, the nature of AI remains obscured, sometimes controversial in the eyes of public. Before stepping into the world of AI and machine learning, we need to understand the AI technology that academia and industry are talking about.
Artificial intelligence, or AI, as the name implies, is intelligence demonstrated by machines, as opposed to natural intelligence displayed by humans. Now, Helen, let me ask you a question. Before you join the MindSpore community, what do you think of when you hear the term AI?
The first things that come to my mind were the AIs I've seen in movies, novels, and games. Like the robot in the early sci-fi film Metropolis, the evil Skynet in Terminator, the Matrix, and Cortana in Halo. Then I think of the voice assistants nowadays, such as Apple's Siri, Amazon's Alexa, and Celia of Huawei.
Yes, and Microsoft named the AI assistant in Windows 10 after Cortana. Now, fiction has sort of become reality. AI has become a popular theme in fiction for a long time, and the trend is picking up. The number of AI-themed movies released in the 2010s is nearly doubled compared to the previous decade. This reflects a growing interest and awareness of the technology.
However, my current knowledge of AI tells me that the interpretation of AI in most fiction stories is far from the AI technology in real life, at least for now. The AI that may be taught to behave like a human mind, to be intellectual in every sense of the term, to have experience, beliefs, as well as the other cognitive processes that are generally solely attributed to humans, is closer to another concept, artificial general intelligence, AGI, which is also referred to as strong AI or full AI. Strong AI is currently more of a concept than a method of producing AI.
In contrast to strong AI, weak or narrow AI is attainable due to the way it defines intelligence. It is also the idea behind AI development nowadays. Weak AI does not attempt to fully replicate a human mind, but focuses on creating intelligence focused on a certain job or subject of study, such as computer vision, speech processing, and natural language processing.
Now, here comes today's first question. Keep in mind that you need to choose all correct options. The question is, what's the difference between strong AI and weak AI? A. Strong AI is intellectual in every sense of the term. B. Weak AI is intellectual in every sense of the term. C. Strong AI is intelligence focused on a certain job. D. Weak AI is intelligence focused on a certain job. Now, type your answer in the chat window for a chance to get a gift card.
Okay, go, go, go. A, B, C, or D. Get your answers in. First one to get it right.
Okay,
It's a
let's see.
prize.
Well, congratulations, you got it right. The correct options are A and D. Please contact us by sending an email to public@mindspore.org to claim your gift. We would like to hear about your experience in open source software and your opinions on MindSpore. And don't forget to tell us about your country or region so we can get a gift card you can use.
Now, AI has been widely used in various fields and industries, but how has it evolved to where it is today? To answer this question, let's look back at the birth of AI as a concept.
The world was familiarized with the concept of artificially intelligent robots in the early 20th century. It began with the humanoid robot that impersonated Maria in Metropolis and continued with the T-Man who seeks the heart in The Wizard of Oz. By the 1950s, the concept of AI was culturally assimilated in the minds of a generation of mathematicians, philosophers, and scientists. Among them, a young British polymath, Alan Turing, explored the mathematical possibility of AI.
In Turing's paper in 1950, Computing, Machinery and Intelligence, he suggested that humans use available information and reason to solve problems and make decisions, so can machines. This was the logical framework of the paper, in which he also discussed how to build intelligent machines and how to test their intelligence. His test is called the Turing Test, originally named after the imitation game.
Now I understand why that movie about Turing is called The Imitation Test.
That's right, played by the wonderful Benedict Cumberbatch, England's finest. The purpose of the Turing test is to determine whether a computer could imitate a human. The standard interpretation of the Turing test involves 3 players, human players A and B and a computer. A plays the role of interrogator and communicates with other players through written questions. If A cannot differentiate between which responder is human and which is a computer, the computer passes the test and is considered to be able to exhibit intelligent behavior.
This test reminds me of the reCAPTCHA tests when I try to watch YouTube videos. I'm not a robot.
Not a robot. Actually, an interesting fact is that some researchers use the spam protection methods similar to reCAPTCHA to collect data for AI model training. For example, humans click the images that include a cat and the images that can be used to teach computers what a cat looks like. However, a computer that can tell cats from dogs may not be considered intelligent. So, today's second question is, which of the following is true about the Turing test? A. The Turing test measures how smart a computer is. B. The purpose of the Turing test is to determine whether a computer can imitate a human. C. Websites use the Turing test to distinguish between the human and automated access. And D. To pass the Turing test, a computer must be able to render words as speech.
Okay, after I count 3, 2, 1, please enter your answer in the chat window. 3, 2, 1, start.
Go, 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 go.
Okay. Please remember, before you enter your answers, please leave your experience in open source software and your opinions on MindSpore to us. And also, please send an email to public@mindspore.org to claim your gift. Our assistant will add you if you're the first to answer.
Okay. We'll go to the answers then.
Okay.
The answer is B. B is the correct answer.
Congratulations.
Congratulations if you win.
Okay, and don't forget to contact us by email public@mindspore.org to claim your gift. Unfortunately for Turing, computers back then needed fundamental change, which stopped Turing from getting to build an intelligent machine. Computers before 1949 couldn't store commands, only execute them. Besides, computing was extremely expensive in the early 1950s. The cost of leasing a computer ran up to $200,000 per month. In inflation-adjusted 2010 dollars, such a computer could occupy roughly 100 square meters and consume over 100 kilowatts.
The proof of concept wasn't initialized until a few years later. In 1956, logic theorist, a program considered to be the first AI program, was presented at the Dartmouth Summer Research Project on Artificial Intelligence. In this historic conference, people aligned with the sentiment that AI was achievable.
From 1957 to 1974, AI flourished because computers could store more information and got faster, cheaper, and more accessible. Machine learning algorithms improved, and people became better at choosing algorithms for their problems. In 1968, Arthur Clarke and Stanley Kubert stated that by the year 2001, we will have machines with intelligence that matched or exceeded humans. However, breaching the initial fog of AI revealed a mountain of obstacles. Computers still couldn't store enough information or process it fast enough. Ahead was the first winter of AI from 1974 to early 1980s.
In the 1980s, the expansion of algorithms and a boost of funds reignited AI development. The Japanese government invested $400 million in expert systems and other AI-related endeavors as part of their fifth-generation computer project. Companies and governments threw huge amounts of funds into AI projects with the goals of revolutionizing computer processing, implementing logic programming, and improving AI.
Wow, that's a lot.
Despite the money invested, much of the ambitions proved unsuccessful. AI once again fell out of the limelight.
Okay. Ironically, during the 1990s and 2000s, AI thrived and achieved many landmark goals in the absence of government funding and public hype. In 1997, IBM's Deep Blue defeated the reigning world chess champion Garry Kasparov. Do you know why this match was highly publicized?
No, I do not.
Because it was the first time a world chess champion lost to a computer.
Wow.
In the same year, Dragon Naturally Speaking was released on Windows 95. These events marked two huge steps forward, respectively, in the directions of AI decision-making and spoken language interpretation.
So although we haven't gotten smarter about how to code AI, the fundamental limit of computer storage and speed that was holding AI back for decades was no longer an issue. This can be partially explained by Moore's law, which estimates that the memory and speed of a computer doubles every year. This is precisely how Deep Blue was able to beat Garry Kasparov in 1997, and how Google's AlphaGo was able to defeat Chinese Go champion Ke Jie in 2017.
Wow, that was a big hit that days. As you can see in this brave history of AI development, it is truly a roller coaster of success and setbacks.
It really is. As AI technology evolves, many branches are sprouting from the tree of AI. The research directions in the AI field are roughly categorized in 6 major subfields.
What are they?
Well, number 1, the first is machine learning. Machine learning is based on the concept that machines can learn from data, recognize patterns, and make decisions with little or no human interference. In ML, machines are provided with information and allowed to learn for themselves without being explicitly programmed.
Yeah.
Machine learning has given us everything from self-driving cars to practical speech recognition, effective web search, and a vastly improved understanding of the human genome.
The next one is deep learning. In deep learning, also known as the self-learning of the machines, the machine processes and analyzes the input data using a number of ways until it identifies a single acceptable output. Deep learning is based on artificial neural networks. The adjective deep in deep learning refers to the use of multiple layers of the network.
The third is a neural network, which is an important part of AI research. Neural networks make use of neurology and mimic the human brain, which is an infinite number of neurons.
Yeah.
The neural network's purpose is to code brain neurons into a system or computer. The artificial corresponding neurons of the brain are known as the perceptron.
The next is cognitive computing. The objective of cognitive computing is to initiate and enhance human-machine interaction to accomplish complex tasks and help in problem solving. While working with humans on a variety of jobs, machines learn and comprehend human behavior and sentiments in various conditions, and then recreate the human thinking process in a computer model.
Next is natural language processing, or NLP, which aims to give computers the ability to interpret, identify, locate, and process text and spoken words in as much the same way that human beings can. The various types of translators that convert one system language into another are examples of NLP systems.
Okay, what's last? computer vision. Computer vision is a very vital part of artificial intelligence, as it enables computers to automatically recognize, analyze, and interpret the visual data from the real-world images, or sometimes images from a virtual world. Well, in terms of applications, AI technologies are classified into computer vision, speech processing, and NLP.
3 levels of computer vision can be achieved: image processing, analysis, and understanding. Low-level operations include image upsampling and downsampling. Mid-level operations extract details such as edges, directions, and textures, and high-level operations perceive the objects and scenes in the image.
So do you know what tasks in computer vision include?
Please tell me.
Okay, so the first one is classification, to determine the types of objects in an image.
Good.
Second one is detection, to locate and identify the objects. And third one, segmentation, to compose instances and semantic segmentations and determine which object or thing each pixel belongs to.
As for speech processing, the main tasks include text-to-speech or TTS and speech recognition. For example, in a voice assistant scenario, the voice input is recognized and converted into text data, and the computer executes the task as instructed, and then voice input is generated through TTS.
NLP is another significant application of AI. During NLP, natural language understanding and analysis from a hierarchical process consisting of these layers. Through this process, machines understand and analyze different types of information related to written and spoken languages that are unique to humans and generate human languages.
So tasks that involve NLP include classification, such as spam classification, sentiment analysis, and intent identification; clustering, such as event aggregation and typical opinion mining; sequence labeling, such as named entity recognition, semantic labeling, part of speech labeling, and word segmentation; sentence pair relationship judgment, such as natural language inference, Q&A, and text semantic similarity; and generation, such as content creation, machine translation, and text summarization.
Wow, that's really a lot of them. Yeah.
Okay, and time for another question. As AI technology evolves, many branches are sprouting from the tree of AI. But which of the following are the 6 major subfields? There could be more than one correct answer.
Yeah.
We have machine learning, neural network, cognitive computing, natural language processing, computer vision, deep learning. Send your answers to the chat window.
Well, this time I will let you count down.
Oh yes, thank you very much. Ready? A, B, C, D, E, F. More than one right answer. 3, 2, 1, go.
Okay. Here's your time to type down your answers. Also, we would also like to hear your experience in open source software and your opinions on MindSpore. Please don't forget to write that. Oh, and don't forget to tell us about your country and region so that we can send your gift card.
Okay.
Okay, time's up.
Time's up.
Okay.
If you answered correctly, then all of the following were the major subfields of AI.
Yeah, and remember to send us an email to public@mindspore.org to tell us about your country and region and your interests in open source software so that we can send you the prize.
Our lovely assistant will have added you if you are the winner.
Yeah.
The current AI development is in the phase of perceptual intelligence. That means our machines now can understand the textual, visual, and audio information, make judgments based on the perceived information, and take simple actions.
Yeah, right. We're now living in an era of big data. The huge amount of information we collect every day is so cumbersome that human cannot process such information. The application of AI-enhanced solutions and technology in this regard has proved fruitful in industries such as banking, marketing, and entertainment,
among others. Other AI implementations can be found in a whole wide range of applications in virtually all industries and everyday settings.
Yeah.
In online store scenarios, AI-powered assistants can answer instantly basic questions, find products, or communicate with the order statuses, while online video platforms and streaming media platforms employ intelligent recommenders to provide users with tailored content.
Yeah, that's right. Medical and petrochemical industries are using molecular simulations powered by AI to discover new drugs and catalysts. And your mobile phone is likely to have AI implemented for face or fingerprint recognition to protect your sensitive data.
If AI continues down this path, it will become the most transformative technology that humanity has ever developed.
Yeah, indeed.
In 2022, some breakthroughs and developments are likely to push the boundaries of AI capabilities.
Well, for example, language modeling, which is a process that determines the probability of a given sequence of words occurring in a sentence, allowing machines to understand and communicate with us in language we understand, or even transform natural human languages into computer code or programs and applications.
Following the current state-of-the-art language GPT-3, its authors are working on a successor, GPT-4, which is believed to be able to hold conversations that are indistinguishable from those of a human and become much better at creating computer code.
Cybersecurity AI is another promising topic. As machines take over more of our lives, hacking and cybercrime inevitably become more of a problem. Every device you connect to the internet is inevitably a potential point of failure that an attacker would use against you.
What's worse, these points of failure are harder to identify due to the complexity of the networks. This is where AI can play a role in keeping our devices safe, by analyzing the network traffic and learning and recognizing patterns that suggest malicious intentions. The variety of AI applications used in industries can be seen as an ecosystem. This diagram shows the components of the AI ecosystem.
The internet, sensors, Internet of Things, and servers with high-performance processors form the underlying infrastructure of this ecosystem.
Yeah, this infrastructure is the foundation of base technologies of AI, that is, big data and cloud computing technologies. These base technologies are combined with AI elements, including data, algorithms, and computing power.
One thing that AI algorithms require is massive amounts of data. NLP, for example, would not be possible without millions of human speech samplings broken down into a format that AI hardware can process.
Another thing is computing power. AI can be viewed as a massive series of math problems that learn to correct their own mistakes. This characteristic requires enormous computing power, which is exactly what premium cloud computing delivers.
Indeed. With these facilitators, AI algorithms drive the technical directions of AI, such as computer vision, speech processing, NLP, and more. The technical research results will then power AI applications in various industries.
AI has entered the new stage of becoming fully commercialized. It is influencing traditional industries in different ways and driving changes in the ecosystems of these industries. We are seeing changes at 3 levels.
The first is the change at the enterprise level. AI has been involved in the management and production processes with the trend of being increasingly commercialized. Relatively mature AI applications have been implemented by and deployed in some enterprises.
These enterprises are now capable of making use of user information, collected from multiple dimensions via various technological means to provide consumers with related products and services. In the meantime, the insights into development trends gained through optimization allow the enterprises to satisfy potential demands of consumers.
The second is change at the industry level. AI is reshaping the relationship of upstream and downstream sectors on the traditional industry chain, such as healthcare, retail, digital government, and agriculture. The types of upstream product providers have been expanded because of the engagement of AI. Users of the products are shifting from individual consumers to enterprise consumers.
And the last is labor change. New technologies powered by AI is enhancing the efficiency of information utilization. Such technologies include augmented reality, gesture recognition, and robotics. In addition, more robots are widely used to replace labor in repetitive tasks, leading to the increase in the percentage of technological and management personnel. These are the changes in the labor structures of enterprises brought by AI.
The technologies that support AI are also advancing in the past decade. Breakthroughs in AI algorithms are observed, especially in the vision and voice processing domain.
And I must mention data. The mobile internet era we are experiencing brings explosive growth in data volumes, providing more and more samples for machine learning.
The development in big data technology also lowers the cost in time and money to obtain labeled data required for learning.
In terms of computing power, the processing capability of chips is improved and the price of hardware is lower, resulting in a sharp increase in computing power. Currently, most AI computing is executed by the GPU, but as technology advances, ASICs and FPGAs are becoming new underlying infrastructure for AI development.
Existing AI technologies are getting increasingly sophisticated. Take autonomous driving as an example. Self-driving cars and drones have achieved significant progress thanks to autonomous and online system algorithm. Now, a self-driving car is equipped with capabilities including obstacle perception, decision-making and planning, cloud simulation, high-precision map service, and end-to-end deep learning.
Speech recognition is another example, which is now a must-have for big companies. Using signal processing and recognition technology, speech recognition enables machines to recognize and understand human language and convert it to text and instructions. Application scenarios of speech recognition include smart TVs, intelligent vehicle consoles, call centers, voice assistants, and smart appliances. Speech recognition products of leading providers achieve over 97% accuracy, with a dictation rate up to 400 words per second.
Computer vision technology is another topic worth mentioning. Significant progress has been made in computer vision-enabled scenarios such as augmented reality, image search, beauty effects, and intelligent security.
And you may be wondering, with all this progress and all of these achievements, how exactly does AI reshape these industries? Well, first we'll look at the education industry.
Okay. Main products in the current AI education domain include intelligent adaptive learning system, intelligent assessment, and intelligent accompanying robots.
Intelligent adaptive learning systems provide customized learning solutions in real time based on students' learning status, using methods such as knowledge reserve diagnosis, competence assessment, and content recommendation.
While AI technologies have been used by schools and education companies to track learning status, record learning data, evaluate proficiency, manage learning progress, and connect parents with schools. With the power of open big data, they can challenge traditional learning systems, make teaching more targeted, qualify and visualize learning progress, and improve teaching and learning quality.
Intelligent assessment is another major branch of AI education. It is divided into voice and essay assessment. Voice assessment, or speech assessment, assesses students' oral language automatically from multiple dimensions, including pronunciation, semantic meaning, and expression. Voice assessment has been implemented in many learning systems to help students practice oral language after class.
The healthcare industry is also reshaped as AI-based applications are getting mature. More AI technologies are applied in healthcare industry to simplify complex medical treatment procedures and optimize medical resource allocation.
As of now, AI-based medical products have been used in 3 scenarios: intelligent diagnosis and treatment,
hospital management, and health management.
Yeah, intelligent health management means to apply AI in specific health management scenarios, for example, using medical sensors to monitor health conditions.
Exactly.
It aims to prevent diseases and maintain health through individualized management, which is going to be the mainstream of preventive medicine.
Intelligent diagnosis and treatment is the most important application of AI technologies in the healthcare industry. Computers learn from doctors and medical experts, imitate their thinking, and inference to develop reliable diagnosis and treatment solutions.
That's right. AI also show huge potential for application in manufacturing. Scenarios for AI applications in manufacturing mainly include intelligent products R&D and empowerment, quality productivity improvement using AI, and intelligent supply chain development.
That's right. So, for example, computer vision can be utilized to quickly scan the quality of products, improving the efficiency of product quality control. Furthermore, because of the learning ability of AI, the performance will be improving constantly over time.
Specifically, car companies have been making use of computer vision systems to identify defective parts, including those not covered in the datasets used for training the algorithms.
That's right. Warehouse self-optimization is an important process in manufacturing where AI plays a vital role. Smart carrier robots can significantly enhance the sorting efficiencies in warehouses and reduce labor costs.
We can also take material handling system as an example. Based on production demands, the system assigns handling tasks to robots to complete point-to-point goods handling. Robots transporting goods within a warehouse detect obstacles and adjust moving routes to find the best path.
And AI algorithms would use logistics data, such as data of materials in and out, stocks, and turnover of parts to facilitate self-optimization and operation of warehouses. For example, algorithms may suggest relocating parts with low demands further away and placing parts with higher demands in surrounding areas for quick access.
Nowadays, open source AI and machine learning frameworks such as PyTorch, TensorFlow, and MindSpore enable developers to integrate machine learning, deep learning, image recognition, natural language processing, and other AI features into new software.
That's right. These frameworks provide powerful capabilities to help developers easily implement machine learning algorithms, reducing the overall cost of AI-powered software development.
Okay, question time. Then today's last question is for you. Which of the following are the three phases of AI?
Three phases of AI.
A, computational, B, perceptual, and C, practical, D, cognitive. What's your answer?
Leave your message in the chat box. In 3, 2, 1, answer!
Okay, please leave your message in the chat box.
If you are the winner, our lovely assistants will @ you.
Yeah.
Okay.
Okay, time's running.
Answers in.
Okay.
Okay.
Congratulations. We've got the last prize winner today. The correct answer is A, B, and D. Okay, you know the rule. Contact us at public@mindspore.org to claim your gift, including your country and region and your experience, open source software, and your thoughts on MindSpore.
Perfect. As I mentioned earlier, the development of AI can be divided into 3 phases. From another perspective though, that is AI's performance compared to that of a human, the future of AI is also a 3-step process.
Yes, in the eyes of the public, the ability to complete tasks with performance similar to or higher than that of human is an important indicator of AI development.
So the first step, in the next few years, AI will be catching up with humans in terms of performance in some key fields. As a matter of fact, AI has already surpassed humans in certain fields, for example, computer vision.
While computers are always more acute in perception than humans because they are driven by large amount of data rather than human will. Now, computer vision can obtain more information with higher accuracy. allowing computers to simulate human in performing creative activities.
Yeah, it's interesting that you mentioned the amount of data, as the size of your data used for training is one of the key factors that affects the development of AI.
Yeah.
In many fields, training data accumulation is at the initial stage. Supervised learning is an example where data accumulation requires large amounts of human labor.
Now that data is one of the key influencing factors, what are the others?
Well, besides the size of the data, there are clarity of rules and standards, frequency of exceptional cases, and external factors such as government policies.
Wow. I guess chess is an example of clarity of rules, since it has a simple, clear, and quantitative criteria as a board game.
And you're absolutely right. And healthcare is an example of a scenario with many exceptional cases. There's still a long way to go for AI healthcare.
Next, for the second step of AI in the future, it will go well above human average in the following 1 or 2 decades. AI capabilities are improving in separate technologies and applied to numerous commercial areas rapidly.
Transportation, for instance, has been the fastest growing sector in the application of AI technologies in recent years. AI technologies like autonomous driving will dramatically improve social resource distribution and change our lives.
However, there are still some technical barriers to break before they are fully applied to commercial uses.
Okay, and then the third step of AI would be the age of strong AI. AI will be equivalent to human intelligence in all aspects and able to think, plan, solve problems, understand complex ideas, and learn fast from lessons.
Well, that's magical. Some think that we can produce strong AI if we replicate human brain neurons and synapses of the same magnitude.
I doubt that because, as the Turing Award winner Yann LeCun said, a cat only has 800 million neurons, and our AIs cannot fully mimic a cat. So, extrapolate that, how many neurons does a human brain have? It's non-comparable.
Well, I believe the number is more than 80 billion.
Exactly, and that's 100 times in difference. And where did you get this weird picture? Did you draw it on your own?
It's in fact generated by Dale, a neural network from OpenAI that creates images from text captions for a wide range of concepts expressible in natural language. I entered cats and neurons, and then it gave me this picture. Don't you think it's kind of cute?
It's kind of cute, but it's weird and somewhat unrealistic.
The new generation of Dial will be able to create realistic images and art from natural language description. As far as I know, it's going to be released soon.
Speaking of which, this reminds me of a recent piece of news. A researcher at Google is convinced that Lambda, Google's AI chat box, has become sentient because it shows an in-depth understanding of sentiment in their conversations and has its own feelings.
Wow.
But experts claim that this is simply the result of training based on large amounts of data about sentimentality.
Seems strong AI is still a distant goal.
Realizing strong AI is difficult but not impossible. Despite the obstacles, new technologies like quantum computing are driving AI towards a promising future, the age of strong AI.
Yeah.
In the next episode of MindSpore Tech Day, we will talk about the history and development of AI frameworks. So stay tuned if you want to learn about the facts and challenges that drive AI frameworks to evolve and how AI frameworks are going to play a key role in the democratization of AI and data technology.
Thank you for joining us today, and thanks for watching.
Yeah, thank you, Helen, and thank you to our production team who could make this live stream possible. Remember, join MindSpore community.
Let's open source together.
Thank you for watching and see you next time.
See you.